It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Good morning, all of you, and we are discussing this combinational circuits. We are dealing this combination circuits and all. Fine. Last class we have completed this adders, subtractors. We have seen parallel adders. We have discussed. Let's continue our discussion. And today's class will talk about this multiplexers. And we'll talk about what multiplexers will talk. All of you. Take down multiplexers. The multiplexers, the different names for these multiplexers. This multiplexer, which is called as a data selector. This is called as a data selector. And this is also called as a many to one selector, which is also called as a many to one. And this is also called as a universal logic circuit. Universal logic circuit. I will tell you why it is called as universal logic circuit. As we know, what is when a universal logic gate means what? All other gates we can implement by using the NAND and NOR. That's the reason we used to call the NAND and NOR is called as universal circuits. The same thing here. By using multiplexer also we can able to implement all others. We can able to implement. That's the reason which we used to call this a universal circuit also. The another name is that is parallel to serial converter. What is that? Parallel to serial converter. So the parallel data will be converted to a serial data. There are different names for these multiplexers. Yes. Let us do the analysis of this multiplexer one by one. So consider this is the general structure of this multiplexer. The general structure of this multiplexer is what? 2 power n cross 1. 2 power n cross 1. What is 2 power n is a? 2 power n is a number of data inputs. Number of data inputs, or we should call this as a number of data lines. This is a 2 power n cross 1. This is the number of data lines. And n is the number of select lines. N is the number of select lines. And this 1 is the number of outputs. And this 1 is the number of outputs. This is the basic structure of any multiplexer. 2 power n cross 1. That means it has a 2 power n number of inputs, 1 output, and select lines. Now if I take this n is equal to 1, so this is the order, general order of this marks is what now? 2 by 1. Next, if I take n is equal to 2, this is a 4 by 1. Now this is 8 by 1, and this is 16 by 1. In all the cases, you can see how many outputs are there. How many outputs are there? Only one output. Only one output. Yes, the inputs are what now? Here you can see 2, 4, 8, 16. 2, 4, 8, 16. These are the inputs. Then how many select lines here? In this case, how many select lines are? One select line. In this case, how many select lines are there? Two select lines are there. In this case, how many select lines are there? Three select lines. In this case, how many select lines are? Four select lines. All of you, these are the select lines. This is the general structure of any multiplexers. Fine. Next, let us consider a 2 by 1 multiplexer. Consider a 2 by 1 multiplexer. The basic structure of a 2 by 1 multiplexer is like this. Here we have taken as these are the two inputs. 0, 1 is the inputs. And how many outputs are there? How many outputs are there? We have only one output. This is the output Y I am calling. How many select lines required? How many select lines? Only one select line is required. This is the select line. Only one select line is required. Now this is the select line. SC the select line. Now according to the select line, it will be, so here we can treat this as, this is like a junction. This circle, this is like a junction. Let us consider two vehicles are coming like this. One vehicle is coming this path, the other vehicle is coming in this path. The two vehicles are coming like this, and these two vehicles has to go to in this path. Yes, let us consider this is the traffic signal, the traffic constable. According to the signal given by this traffic constable and which person will go, that will be decided. That is select lines. For example, if they has given a select line, if they has given a select line yes value, if they mentioned as a 0, select line is 0, that means this path will be established here. This path is established. Yes, yes, then output will get what now here? Output, what I will get now here? I naught. That means whatever the person is in this path, that data will be passed to this output. If the S value equal to 1, if S value equal to 1, if S value equal to 1, then what now here? Then who will go to this output now here? When S value equal to 1, so this person will be, the connection is established here. Here the connection is established. Then output Y, which will be equal to what now here? Here this is a I1. According to the select line, which person will be go, that will be depends. Right. So you can see the truth table, we can develop it now here. Now you can see this is my select line and this is my output here. When S value equal to 0, what is the output? It will be a I naught. When S value equal to 1, output is what now here? It is a I1. Isn't it? So from this we can write the general expression of this Y. Tell me how I should write this expression of Y. When this is S is equal to 0 means S bar into I naught, S bar into I naught plus this is S into what we can say, this is I1. This is the general expression of this multiplexer. In case of a 2 by 1 mux, we have seen this is. Fine. Let us see this multiplexer, this select line, like we can consider switching action. This is like a switch we can consider. Now let us see this as a logic circuit, we can say. What we are getting now here, output Y, which we are getting this as what now here? S bar into I naught, isn't it? Plus S into I1 now here. S bar into I naught and S into I1. So we can consider here. So these are the lines we can consider here. So this is the data here. Here this data, this I am calling this as a I naught and this data is a I1. And these two are given to your AND gate now here. AND gate we have taken here. This is the AND gate. What is this input for this AND gate? You can see The input for this AND gate is I have taken one more input I have taken here. This is the another input I have taken. This is my S I'm calling. This is S. And here this is a S bar. This is S bar. You can see here. This is S and this is S bar. You can tell me the connections now here. Here for this first AND gate, what are the connections we have? It is a S bar into I naught. S bar. Here is a S bar and I naught. Here is a I naught. Next, what now here? S into I1. So this is a I1 and here is a S. Now, and these two are passed to a what now here? OR gate. These two are passed to a OR gate like this. Then Y will get now here. What is the Y I can get now here? This is which is equal to S bar into I naught plus S into I1. The internal structure, it could be like this. All of you. This is the logic circuit of a 2x1 multiplexer. This is the logic circuit of a 2x1 multiplexer. Done. Now let's talk about this 4x1 multiplexer. Now you tell me for the 4x1 multiplexers, how many inputs are there? Tell me how many inputs are there for 4x1 multiplexer we have taken. How many inputs are there? That means this is a 2 power 2 square cross 1. That means how many inputs are there? 4 inputs are there. The 4 inputs we have taken 0, 1, 2, 3. This is the I0, I1, I2, I3. And how many outputs are there? Output for this multiplexer is always 1 only. And how many select lines are required here? Tell me. How many select lines are required for this multiplexer? So 2 power n form now, 2 power n cross 1 here. How much is n value here? 2. So n value 2. So 2 select lines. So this is, we are calling this is S0 and this is my S1. You should mention always, this is the LSB, this is the MSB. Yes, S0 and S1, these are the select lines. Now you tell me how this operation here, you can see how this operation now here, let us say this is S0 and this is S1. Do correct it. S0 and this is S1 and this is S0. Do correct it. Let us say when both are 0, 0 is the input now. When both are 0, 0, what happens now here? When both are 0, 0, so then both 0, 0 means what is the decimal equivalent of 0, 0? 0. What is the decimal equivalent of 0, 0? 0. So this is, and which is connected to 0, you see this thing? This is 0 now, which is connected to 0? I0 is connected. So this output I will get this as I0. Isn't it? Look at now here. When both are 0, 0, what the decimal equivalent of 0, 0 is a 0. That means what now here? This fellow will go here. This connection is established here. And whatever data is coming from here, the data will be passed to this output here in this path. I will give according to my conditions, I will give this thing, my requirements. If I say both are 0, 1, if I say, then what happens now? What is the decimal equivalent of 0, 1? 0, 1. Decimal equivalent is 1. So here 1, which is connected to 1. Here 1, which is connected here. This is I1 is connected now here. I1 is connected. So that means what now here? This will pass here. This connection will establish here. Then this fellow will go here. This is I1. All of you. Next, if I say this is 1, 0, then tell me what happens now. If it is 1, 0, what is the decimal equivalent of 1, 0? 2. So that means which will go here. So this I2 connection will be established here. Next, 1, 1, 1, 1, which will go here. That is 3 will go. This means what now here? I3 will go. All of you understood this working now here? Understood this working? Now, by this truth table, we can write the expressions. We can write the expressions. Tell me how we can write this expression. Tell me here now here. Y equal to what you tell me. When both 0, 0 means what we can say this is S1 bar, S0 bar, both 0, 0 na? Yes, into what we have this is I0. All of you. Yes, next. This is what now here? S0 bar. Next, what now here? S1 bar, S0, which will go here? I1 will go. Next, what now here? S1, S0, which will go here? I2 will go. Plus, next, what we can say this is S1 and S0, which will go here? I3 will go. All of you understood this equation? All of you understood this equation? Done? The same manner we can see for this as a 8 by 1 marks also. 8 by 1 marks, 16 by 1 marks. Right? So to understand this thing, let us do some basic problems here. Let us solve some basic problems here. Take down these problems here. Now you tell me this is. Yes. Now these expressions here, this min terms, the here this is the connection they has given us what now here A, B, C now select lines and where Y is the output. Now you can tell me here. Yes, combination 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. All of you. Next 1, 0, 1, 1, 1, 0, 1, 1, 1. Now you tell me this is. If all are 0, 0, 0, then which will go? Decimal equivalent of 0 is 0. So for 0, which we have connected now here, 0 is connected. So output equal to 0. When 0, 1, 1, for 1 which I have connected here, 1 is connected. Data 1 is connected here, 1. Next for 2, which is connected 2 now here, 1 is connected here. And next for 3, which is connected now here, 0 is connected. All of you. Next, this is 4. For 4, which is connected, 1 is connected. And 5, which is connected here, 0 is connected. And for 6, 1 connected. 7, 1 connected. All of you. Right. So from this, we can write the expressions now here. So tell me, how we can write this Y expression, you tell me? Y is equal to what we can say here. Now here, this expression we can say this is A bar, B bar, C bar into what now here? 0. Yes or no? This into 0 plus what now here? A bar, B bar, C into what now here? This is 1 plus. Next, what now here it is A bar, B, C bar into 1 plus this one. This is A bar, B, C into 0 Yes, so this is what else now here? Yes, A B bar C bar into 1 plus A B bar C into 0 plus A B C bar into 0 plus A B C into 1 now here. So finally what we have now here, this into 0, we have what are the left out now here, this term left, this term and this term, and this term sorry left now here. So finally what we can say, y value what I can get now here is a bar B bar C, yes, plus A bar B C bar plus A B bar C bar plus A B C. Any other left? 1, 2, 3, 4 only now. 1, 2, 3, 4, 5. 5 is left. Something one is missing here. 1, 2, 3, 4. One is missing here. This is 1, 6. This is 1 here. Okay, this is 1. Yes, A, B, C bar. Okay, like this we should write. Yes, you can say the next one. Find the logic expression. Find the logic expression they ask. Now you tell me this is the logic expression I want to find. Here they has S1 they connected to P, S0 they get connected to Q, they has connected. Yes. Now can you write these expressions now here? Y expression. What I can say now here? The table we can form. Yes. The table, if I say this thing here, tell me this thing, the table now here. Now we can say this is what now here, PQ, and this is Y. When both are 0, 0, what I will get now? R. Both are 0, 0, will get R. This is 0, 1. What I will get now here? This is R bar. 1, 0. What I will get now here? This is R bar. Next 1, 1. What I will get now here? R I will get. Everybody. So from this I can write the expression. Tell me the expression now here. This is P bar Q bar into what now? R plus what? P bar Q into R bar plus what we can say here? PQ bar into R bar plus what we can say? PQ into R. All of you check it. All of you check this thing. Yes sir, no. Everybody got the same thing. So here from this, can you tell me the min terms here? What are the min terms are here? This is min terms. What we can say here? This is what now? 1, and this is what now? 2, and this is what now? 4. This is 7. This is what is a 1, 2, 4, 7. What is 1, 2, 4, 7? Which is called as what? 1, 2, 4, 7, which is called as XOR operation. So this is what we can say, P XOR Q XOR with R. 1, 2, 4, 7 operation, which is called as XOR gate now. P Q R. Fine. Yes, all of you. We'll move to the next problem, all of you. Next, take this thing here. Find the logic expression. Find the logic expression Now they ask him to find the logic expression. They ask him to find, right? Now see this thing, how we can do this thing, this logic expression. Now here, we will do this part here. Let us call this, I am calling as x1. Yes, this I am calling it as x2. Y is equal to what I can say, x1 plus x2. Y is equal to x1 plus x2. So can you tell me the x1 first? X1. Can you write directly now? Here we have seen now. So x1. What is x1 now here? A, B, C. Tell me here. When A bar, B bar, C bar now here. Wherever we have 1, those only will be a min terms now here. And here on all these cases, this value it is connected to 0. This term will become 0. And this also will become 0 now here. Only these are the min terms we'll get. Yes. Plus next what we'll get now here? A bar, B bar, C plus A bar, B bar, C. Yes, this is 3. And next 6. What is the 6 now here? Yes, A, B, C bar. This is my x1. What are the x2 now? Tell me here. Here this is C. Here what will get now here? C bar, C, and this is C bar. So finally, y is given as what now here? X1 plus x2. R gate now. X1 plus x2. Sum of these two, what we can say, this is A bar, B bar, C bar plus A bar, B bar, C plus A bar, B, C bar plus A, B, C bar plus again C bar. So from this, what we can say, this is y is equal to, if I take the C bar common, then this is A bar, B bar plus A bar, B plus A, B plus 1 plus A bar, B bar, C. So what I will get now, y is equal to, this is C bar into this is 1 plus A bar, B bar, C. Check it all of you. 1 plus anything is a 1 only. And next, after this, what I can do, I can apply the distribution property. That is what we can say, C bar plus A bar, B bar into what I can say here, C bar plus C, C bar plus C, which is equal to 1. So from this, what we can say, y is equal to C bar plus A bar, B bar. Check this thing. Then finally, we'll get like this. Fine. Yes. Sure, next problem. Now see this expression. Let us say they has connected like this, they has connected. Can you tell me here? Let us call this is a yx, consider. Don't take this as. This is the y we need to get. Now I'm calling this is something x. Can you tell me x now here? Can you tell me the x now? How to write this? X is equal to output of the first multiplexer. When this is equal to what now here? B bar into what now? 0 plus B into C bar This is my select line. Select line is given as a B. All of you. So that means X means what now here? BC bar. X means what now here? BC bar. Now here we have, this is the X. Now this is a select line now. Select line. Tell me what I will get this Y now here. What I will get Y now here. So which is equal to, yes, what I will get Y now here. Y is equal to, if we get A bar into 0. Next what we can say here. X bar into 0. X bar into 0 plus what now here? X into A now. So that means Y is equal to what we can say. X means what here? A, B, C bar. This is the final expression. Like this. Done. So with this, I think all of you might have some idea about this, how to do the implementation of this mux. Right. Like this. We can solve this, all the variety of problems we can solve it now here. Right. Now can you tell me this problem? Can you tell me this problem now here? Now tell me here, what I will get this Y now here. Here this is given C, this is D, and this is what now here? C bar. And here this is what now here? C bar. Here we have C bar into D bar, isn't it? C bar into D bar. Now tell me what I will get this Y now here. This is A bar B bar into C. I love you. Next A bar, this is S0, this is S1. Okay. A bar B into D plus A B bar into C bar plus what we can say, this is A B into C bar D bar. This is the expression. This is the expression now here. Now they ask him to find this min terms. How to get this min terms now here? The expression we should write now here. This is which is equal to, this is what we can say here. A bar B bar C. Yes, so the D is missing now. So what we can say, once we place a D bar, yes, next A bar B bar C, next is a D. Yes, this is this two now here, these two will get here, isn't it? Plus next here what now here, second one is a B bar C. C is missing here. This is a C bar into D plus what we can say here, A bar B C into D, C into D. Now one C bar here, the next one is a C. Next third one, tell me the third one here. D is missing now here. A B bar C bar D missing. So it is once D bar. The next case is what now here? A B bar C bar into D. Isn't it? Next here all present, no problem. So this is A B C bar D bar. Now we can tell me the min terms now here, which is equal to sigma m of what now here? This is what now? 2, this is 3, and this is 4 plus 1, 5, and this is 7, and this is 8. Yes, this is 9, and this is 8 plus 4, 12, These are the min terms now. Right, understood how we have written the min terms. Right. Now tell me this thing. Now tell me this thing here. The logic expression of this four output of the 4 by 1 multiplexer shown below is. What is this multiplexer here? And here this S1 which is connected to ground here. So this value always 0. This is connected to what? Ground. So this is always 0. Isn't it? S1 is always fixed. There is no other combinations. So what are the possibilities will happen now here? S1 value, yes, we can say here, if you draw it, the table here, how the table it could be here like this. Now here this is S1 and this is S0 and this is the output Y. Now you tell me now, S1 value 0, S0 value 0 maybe. Yes. Yes, this is what now here? S1 again 0 only. It is, we cannot take this as a 1. Fixed now, it is not a variable, constant value they connected. And this S0 value 1 only. Yes. When the 0 0 0 0 means which is connected now here, it is a is connected now 0 0 1 means which is connected 1 we have connected. All of you, can I take these other combinations? Can I take this? This is 1 0 combination. Can I take? No, here this S1 is always fixed. We cannot take the S1 value. S1 value, if it is a variable, we can take, but it is not a variable now, fixed value. So now what I can write this expression you tell me here, which is equal to what we can say here, S1 bar S into S0 bar into A plus S1 bar S0 bar into 1 here. So which is equal to what we can say Y. S1 is what now here? This is 0 bar. S0 is connected to B now. So this is B bar into A plus S1. This is 0 bar. S0 is connected to B into 1. What I will get now? Y is equal to what I will get now? This is A B bar plus what now here? B. So what we can do, distribution property which is given as A plus B into what I can say here, B plus B bar. B plus B bar is a 1. So what I will get now here, A plus B. So which will be given as A plus B. All of you. Next one. And see this problem. Design a logic circuit f of A, B, C equal to the min terms they given as like this, using 4 by 1 marks. Using 4 by 1 by selecting AB as select lines, BC as select line, and AC as select lines. Different cases they has given. First we will see the first bit. Now you tell me here, first of all you tell me, see this thing, how many terms are there? That is 0 to 7. That means how many we have? 8 we have. That means 8 are the min terms, means 8 inputs are there now. How many inputs are there? 8 inputs are there. Yes or no, first of all? Yes, to implement this thing, eight inputs. You tell me here. 8 means what we can say here? 2 cube 1. So what is this mux? What is the size of the mux required? What is the size of this mux we required now? Here it is 8 by 1 mux is required. 8 by 1 mux. But they are asking what now here? By implement by using only 4 by 1 mux only, not 8 by 1 mux. They are saying that do this thing by using only 4 by 1 mux only. I don't have 8 by 1 mux. For this, what we need to do? Let's see. For this, what we need to do? We'll see this thing here. The first bit, what we are doing now here, we are taking this as AB as a select lines. AB I'm taking as select lines. AB the select line means what is the other one is a C. C we should not take as select lines, isn't it? Since here AB as select lines, I can take this AB here in this now. First, what are the combination we can take now here? We'll form one table we can form here. Horizontally, vertically. Yes. Now here we have taken, here we can take this as AB combinations. And here this is vertically, we are taking the C combinations. We have taken. Vertically, we have taken C combinations. So here, this C combination means what we can say C bar and C is a possibilities. And in AB, the combinations are, tell me how I can take in AB combinations. First, we can take this as A bar, B bar. Next, what we can say this is A bar, B, C bar, A bar, B. Next, what we can say this is A, B bar, and this is what now here AB. This is not a K map. No need to worry about the one bit. No need to take the gray code. This is not a K map. So simply take the table like this. All of you. Now we'll see this thing here. Now you can see this thing here. Like a table we have formed like this, isn't it? Now you can see here. Tell me this combination now here. This is what we have. This is here we have A bar, B bar, C bar, and this is what we can say. This is A bar, B, C bar, and this is A, B, C bar, and this is A, B bar, C bar, A, B, C bar. And this is what now here it is A bar, B bar, C, intersection of rows and columns. And this is A bar, B, C, and this is A, B bar, C, and this is A, B, C, isn't it? Now you can tell me the cell numbers now here. A bar, B bar, C. This means this value 0. This number, this is what this is min term 0 now here. This is what now here, this is min term 2, and this is what now here 4, and this is what now 4 plus 2 6, and this is 1, this is 3, and this is 5, and this is 7. All of you. Yes, this thing now here. Now see the given min terms. What the given min terms are? 0, 1, 3, 6, 7 given. 0 given now. 0 given. So round it. Yes, 1 given, round it. Min term. Yes. And 3 given, round it. 6 given, round it. And 7 also given, round it. Fine. Understood this thing here? These are basic. First, we have given the numbers. After that, whatever the min terms they given the problem, those things we have circled it simply around it. We have circled simply. Now, what we can do here, this is What now here? This is min term. Min term 1 into C bar. Min term means what now? This is 1 into C bar. 1 into C bar plus 1 into C. What this is a C bar plus C means what? 1. All of you. This is a min term. Min term means what? 1. 1 into C bar plus 1 into C. This is 1. Next here, this is not a min term. That is 0 into C bar. Yes, 0 plus what we can say here? 1 into C. So this value, how much now? C. Right. Next here, 0 plus 0. That means this is what now here? 0. Next, this is what we can say here? 1 into C bar plus 1 into C. 1 into C. Min term now, that is C. So we'll get it as a 1 now here. Understood all of you this thing here? Next, finally we'll implement this thing. See this implementation now. What we can do here is, so what is the size of this mux they are given? The 4x1 mux they given. So take the 4x1 mux. What are the mux size they has given? Take that one. This is the 4x1 mux only they available. 4x1 mux only. So it has a one output. How many inputs are there? 4 inputs are there. 4 inputs we have taken now here. These are 0, 1, 2, 3. How many select lines are there? 2 select lines. This is S1 and this is S0. So this is, so select lines A, B. Now you can tell me now, A, B, when you have taken A, B, A bar, B bar, for A bar, B bar, this is connect, will be what now in case of A bar, B bar, this is 1 now, so I have to connect here, it is 1. Yes, when the second A bar, B, in that case, what now for A bar, B, we have connected to what now, what is the thing? C, so we need to connect C here. Next, what now? Other combination A B bar. For A B bar, what we have is a 0. Connect 0 here. Next, A B case. What now? Here it is a B case 1. So connect 1 here. Then we'll get the required circuit. We can able to implement it. The required logic function. We can able to implement this thing. That's all. All of you done. Right. Now we have implemented this AB, we have implemented. Now I will do this AC, I will do. Yes, you do this BC as a homework. You do this BC as a homework. I will do AC, I will do, you do the BC as a homework. The same manner. Now what I am taking is a third bit I am doing here. So here what the conditions are? BC as select lines. BC as select lines. BC as select lines. So I should take the BC as a select line. I need to take AC. Okay. AC as a select line. Okay. AC as a select lines. Okay. So I'm taking AC as a select lines. So form a one table like this. Just now we have seen a table. This is not a K-map, don't worry. This is not a K-map, so no need to maintain the gray code, no need to maintain. So this AC. So means AC means what I should take now here is A bar, C bar here. This is A bar, C. This is AC bar. And this is AC. All of you. Next here what I should take now? B bar and B. Other line we should take this as here. Now you tell me this is what now it is a, yes, this is what here it is a bar, B bar, C bar now here. And this is what? A bar, B bar, C, isn't it? A, B bar, C bar. and this is A B bar C, and this is A bar B C bar na. This is A bar B C, and this is A B C bar, and this is A B C. Okay. Now we can give these numbers now as usual. So this is what now 0, this is 1, and this is what we'll get now here 4 plus 2, 6 now here. So this is what now here 5. Why it is 6, 5. Next what we have is a, this is what now 2. Here B bar na. So that's why this is what now here 4. Okay. Next here this is 3, and this is what now here 6. This is 7. Check these numbers now. Check these numbers now here. Is it correct now? Now you can see this thing. What are the min term they are given here? 0, 1, 3, 6, 7. 0 is there, so round it. 1, 3, 6, 7. Now you tell me what I will get now here. This is 1 into B bar. Here this is what we can say B bar. And here this is what now 1. Here this is what now B. Here this is what now B. Check it. Now give this, implement it now here. This is a 4 by 1 marks. Now this is a 4 by 1 marks. Yes, this is 0, 1, 2, 3, and we have a select lines S1 and S0. We have one input, output. This is 1. Given here, this is A, this is C. Now, what are the connections I should give here? Input connections I need to give here now. This I should give this as a B bar. This is 1, B, and this is B. All of you. Like this, we need to implement it. Done. The same manner you can do this thing. The same manner we will do the other one. First one is no, not this thing here. This is what 1 into B bar plus what now? This is not a min term now. This is what now here. If it is circle, then only it is a min term. But 2 is not given here. 2 is not given now. That is not a min term. That means that is a max term. Max term is what? 0. 0 into B. What will you get now? 0. Yes, 2 is not a min term now. That is a which are the min terms given? That means that is 1. Here 2 is a max term. Max term is what now? 0. 0 into B, isn't it? That is 0. Right. Done. Yes. Like this, we will implement these things. Like this, we'll implement it. Fine, all of you? Now let's see this thing here. Design a logic gate F of ABC by using what now here? 2 by 1 mux. 2 by 1 mux by using A as a select lines. Now you tell me this is. What is the size we required? You tell me here. What is the size to be required to implement this given mux? How much the size we required then of basically So 0 to, so we have 8 up to 8 we have the values now here. 0 to 7 we have, that means what now here, 8. So the actual size will be required is what now here, 8 by 1 mux is required. So this is the proper implementation. But they given what the size they given is only 2 by 1 mux only, they are saying 2 by 1 mux only, they are saying. So for this what we should do, we'll take only A as a select lines. The other two how to do we'll see now. Here the same as like earlier we can take now here. Now they has given, what they given is a E the select line they given, isn't it? That select line we can take horizontally, remaining lines we can take vertically as we have seen earlier. Now this E the select line, so this I can say this is A bar and this is A. Next remaining two, what else we have, this we can say this as B bar, C bar. Next what we can say, B bar C. Next what we can say here, BC bar, and this is BC. All of you, right? Now you can tell me this is what is this now here, it is A bar, B bar, C bar. This is A, B bar, C bar. This is A bar, B bar, C. This is A, B bar, C. This is A bar, B, C bar. And this is A, B, C bar. This is A bar, B, C. This is A, B, C. Right. Now you can tell me the cell numbers. Now this is what now here, 0. This is 4 now here. This is 1. This is 5. This is 2. And this is 6. This is 3. And this is 7. Right. Now you can tell me this is now here. So what are the min term they given? 0 is given, so circulate. 0, 1, no, 3 is given, circulate. Next 6 is given, circulate, and 7 is given, circulate. Whoever we have circled, those are what? Min terms or max terms? Those are the min terms. Which are not circled, those are the max terms. Now you can tell me how we can take now this min term is 1. 1 into B bar, C bar. This is what we'll get now. This is B bar into C bar. Next, this is what now here, max term, means 0 now here. This value 0. This value also 0. Plus what now here, 1 into this thing. That is what now, BC. All of you. This is what now here is a BC. Isn't it? Now this is over. Next, what about this thing here? This these values are zeros. 1 into BC bar. This is what now here, BC bar, plus what now here, BC. So if I take B common, then it will get the B only now. C plus C bar is 1. C plus C bar is 1. So now we can implement it by using what the size of this mux we required now here. There's given 2 by 1 mux. They given a size is given as what, 2 by 1 mux only. So this is 0, 1, 2 inputs, and we have one select line. This is only one select line, and this is my output Y, isn't it? Now this select line which will be given to A. Now this is what now here, B bar C plus BC. That is nothing but XNOR gate now here. That is nothing but XNOR gate. So I am taking XNOR gate. I have taken. We have connect here, and this is B, and this is C, and this one which is connected to what now here, B. Then we'll get this expression, above expressions. Isn't it? Isn't it? Like this, we will do this thing. All of you. They see the implementation by using what now here? 2 by 1 marks we have implemented. We have implemented the actual size required is what we require now actually to implement this thing here. For 8 by 1 marks, we can implement properly. We can implement properly, we can implement easily, we can implement nothing to do. But here they are asking only for 2 by 1 marks only. How implement this given circuit by using only 2 by 1 marks only, they are saying, isn't it? So then we need to proceed like this. So previously they called the 4 by 1 marks. That's we have proceeded like this, isn't it? Whichever they are saying select line, those lines will take here. Whichever they are saying not select lines, we should take vertically and we'll do the implementation like this. Fine. Right. That's for today's class, and today we did this multiplexes, and tomorrow we'll see the demultiplexes and decoders and encoders we discuss. Decoders, encoders, and demultiplexes we'll see tomorrow. Fine. Okay then. See you. Bye bye. We'll meet in the tomorrow.